In this video, we're going to use trig now to find missing side lengths in a right triangle. So we need to remember that the three trig ratios are sine, cosine, and tangent. And sine of theta, where theta is the angle, is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. So you remember SOHCAHTOA? That can help you remember those ratios, okay? So you will need your calculator today because our calculator is, if you notice right here, if I highlight it, sine, cosine, tangent. On our calculator, that's what we're going to need, okay? Now the first thing we need to do is make sure our calculator is in degree mode because we're going to be dealing with angles in degrees. In future classes, you're going to be dealing with angles in radians. But for right now, we're just going to do degrees. So I'm going to type cosine of 82, and this is 0.9497. But I need to make sure it's the correct answer for what we're dealing with. So I'm going to hit mode right here, which is next to the second button. And I'm going to go down, and you see how this is, you see how radian is highlighted? I need to go down and over to degree mode and hit enter on that, and now I'm in degree mode. So then I'm gonna clear out of this, so second mode will quit out of that. I'm gonna type cosine of 82, and I see I got a completely different answer. Now this second answer, that's what I'm gonna want. So I'm gonna cross this out. Cosine of 82 should give me 0.1392. Okay, so that's just to make sure our calculator is in the right mode. So again, mode, notice how degree is highlighted. That's what we want. That's what we want. So that is set up now for us to be able to solve these problems. So in example 1, we want to solve for x. We've got this angle 31, and we've got this side length 17. So we can't use Pythagorean theorem because we don't have two of the three sides. We can't use one of those special triangles, 45, 45, 90, or 30, 60, 90. Because we don't have one of those angles. We've got an angle of 31, a side length of 17, and a side length of x. So what I'm going to do is identify how those side lengths are related to my angle of 31. So 17 to 31, this is the opposite, and x to 31 is the adjacent. So then I go back to my trig ratios and I say, okay, which one dealt with opposite and adjacent? Well, tangent did. Tangent did. So tangent, and then what do I plug in to sine, cosine, or tangent? I plug in an angle. So tangent of 31 equals opposite 17 over adjacent, which is x. Okay, so you might be asking, well, how do I solve this now? It's got a tangent of 31. Well, remember, tangent of 31 is just a number. We saw that up above. When I did cosine of 82, that just gives me a number. Okay, so how would I solve something like this? Well, we could, since our variable is in the denominator, we could cross multiply. So we've got x times tangent of 31 equals 17. So tangent of 31 is just a number. So what's happening to x? It's being multiplied by a number. So to undo multiplication, I'm going to divide. So I'm going to divide by tangent of 31. So now I'm going to plug this into my calculator. So you see that over to the right. 17 divided by tangent of 31. X equals 28.293. Okay, so we plug that right into our calculator. 17 divided by tangent of 31. So again, it's going to give us a messy side length sometimes, because tangent of 31, if I just look at tangent of 31, that's an irrational number. That's going on forever and ever and ever. Okay, so if I multiply that by another number, it's still going to be messy. So we round it to the nearest thousandths. But x is 28.293, approximately. Okay, so that's how we use a trig function to find a side length. Let's do it again. Let's solve A and B. So we've got this angle measure of 57. 14 to 57, that's opposite. The A is adjacent. And the B is the hypotenuse. Okay, so if I wanted to solve now, I'm going to use opposite and adjacent. That's tangent again. So tangent of what angle? 57. Tangent of 57 equals 14 over A. So if I cross multiply, I got A times tangent of 57 equals 14. So A equals 14 divided by a tangent of 57. So then if I plug that into my calculator, 14 divided by tangent 57, I'll get that A is approximately or equals 9.092. 9.092. Okay, and then to solve for B, I still want to use that 14 because 14 is a nice number. I could technically use this 9.092 now that I have it, but since I rounded that number, I'd rather just stick with the 14 since that's a plain old number, going to be a little bit easier to work with. Okay, so I'm running out of room a little bit. I'll do that over to this side. So what deals with 14 and B? What deals with opposite and hypotenuse? That's sine. So sine of 57 equals opposite, which is 14, over hypotenuse, which is B. So our variable is still in the denominator. So I need to multiply both sides by B or cross multiply. They're both doing the same thing. So I get B times sine of 57 equals 14. So B equals 14 divided by sine of 57. Plug that into my calculator. 14 divided by sine 57. And I will get B equals 16.693. And again, the beauty of math is that we can check our answer. Right? This is a right triangle, so it should satisfy the Pythagorean theorem. So if I do a squared, which was, and I'll do it in my calculator over here, 9.092 squared, plus b squared, or a squared, which was 9.092 squared, plus the other leg squared, which in this case is 14 squared, that's about 278 point blah, blah, blah. And then if I do the hypotenuse squared, which is 16.693 squared, notice how close these are. They are off by 0.008, it looks like. And that's just because we rounded the value of A and the value of B. So this does satisfy the Pythagorean theorem. Therefore, we know we did this correctly using these trig ratios. Okay? So the other thing to talk about is with some application problems. All right, so in here, we've got angle of elevation and angle of depression. Okay, so we've got this person standing right here. They look out and then up, creating this angle of elevation. Similarly, up top in this hot air balloon, you've got a person looking out and then down, creating this angle of depression. Okay? So an angle of elevation or depression is always measured from a horizontal line. Students a lot of times will misplace where an angle of elevation or an angle of depression is, depending on what you need to do. Okay? So, make sure you think about you look out and then up or out and then down. And notice the angle of depression and angle of elevation are the same in this diagram, 38 and 38. Why is that the case? Well, this horizontal line here and the horizontal line here are going to be parallel. So these are alternate interior angles. So your angle of elevation is congruent to the angle of depression. So let's look at an example here. So you're at the top of a roller coaster, 100 feet off the ground. The angle of depression is 44. About how far do you ride down the hill? Okay, so we've got the angle of depression here because you'd be at the top of this hill looking out, right? And then down, creating this angle of 44. A lot of students sometimes want to put the angle of depression here. But notice how that does not relate to a horizontal line, your line of sight. So that's wrong. That's off. Okay? So sometimes you're going to have to draw your own diagram. So make sure you understand the angle of elevation or angle of depression, it has to relate back to your line of sight. If you're on this roller coaster, you are looking out here. Okay? So we've got the 44-degree angle there. The 100 to that is the opposite. The x to this is the hypotenuse. So we've got sine with that opposite and hypotenuse. So sine of 44 equals opposite 100 over hypotenuse x. So our variable is in the denominator. So we got to multiply both sides by x. So we get x times sine of 44 equals 100. So x equals 100 divided by the sine of 44. Plug that into our calculator. And we'll get x is about 143.957 feet. Which makes sense because the hypotenuse has to be the longest side in a right triangle. So that's greater than 100. Okay? So there is another example of how you can use angle of elevation or depression to solve an application problem. Okay? So I've got a couple you try now problems there for you. One thing I do want to bring up real quick, I'm just gonna make a right triangle because all of the problems we dealt with x in the denominator, or our variable in the denominator. So I want to show you an example of what if our variable's not in the denominator, okay? So what if I had an angle here? Let's say this angle is 37 degrees. Let's say that our hypotenuse is 22, and we're trying to solve for this adjacent. Okay, so this is the adjacent, this is the hypotenuse. So that tells me I'm going to deal with cosine. So I've got cosine of 37 equals adjacent, which is x, over hypotenuse, which is 22. So here, our variable is not in the denominator. Our variable is up top. So what I'm going to do is just multiply both sides by 22. So that cancels that out. So x equals 22 times cosine of 37. And I'm just going to plug that into my calculator. So we could plug it in like that, or we could do 22 times cosine of 37. Should be the same thing. And we get x equals 17.57. Because we're going to get a little trickle effect with the rounding there. So 17.57. So that's how you solve one if your variable's in the numerator. Okay, so we did a lot of problems where variable's in the denominator, where we got to cross multiply so that our variable gets up top. Okay, but you could also have a situation where your variable is in the numerator, then you just need to multiply both sides by the number in the denominator to get the x or the variable by itself. Okay, so you've got a couple you try nows, just two. Make sure to practice those. Make sure your calculator is in degree mode. Remember, check your mode. Make sure degree is highlighted. Other than that, make sure you practice this. Understand, you plug an angle into sine, cosine, tangent, and that equals the ratio of the sides. Okay? If you have any questions, let me know. Other than that, just practice. Have a good one. I'll see you soon.